Hello everyone, welcome back to the Numpy crash course. In today's video, we are going to be expanding on the basics by creating arrays using range data, reshaping arrays, transposing data, and using zeros and ones in our arrays. In the previous video, we went over how to create basic arrays, so if you haven't watched that video, please make sure to watch it. The link will be down in the description. So without wasting any more time, let's get right into the video. I have a Google Collaboratory open, and the name of this Google Collaboratory is Numpy Basics 2. Like always, the first thing that we're going to do is to import Numpy as NP, which allows us to use Numpy in all our examples. We're just going to run this code cell so we can use it all the way through. And in the previous video, we used the np.array function to create our arrays. Say we wanted to create an array from values 1 to 3. We would use the np.array function to do so. But say we wanted to create an array from values 1 to 100. This would take a lot of time because the np.array function allows us to create arrays manually, meaning that it's hard-coded. When you have many values in an array, Numpy provides a very useful function which acts in a very similar way as the range function in Python. This function is the np.arrange function, which will return an array with evenly spaced values within a given interval. Let's write some code to take a further look at this. The first thing we are going to do is to create an array using the np.arrange function. Let's call a variable scalar array, and we are going to make this equal to the np.arrange function. And the argument that we're going to pass into this is a scalar. I'm going to get back into this, but the scalar that we're going to put in is 7. See, in the code above, we use a scalar. A scalar is a single value, such as an integer, float, or etc. To read more about this, head over to the Numpy documentation, which will be linked in the description of this video. Let's take a closer look at what happened here, and a good way to do so is by using a visual representation. When one argument is passed, or a scalar value is passed, np.arrange will return values from the default value of 0 all the way up to the number specified, but not including it, meaning the lower end is inclusive while the upper end is not. The output for the code will look like this. Now we're going to run this code. So we're going to use the print and the repr function, and we're going to put in scalar array as an argument. The repr function is just a way to see our code or the output of the code in a more developer friendly way. So we're gonna import numpy as np and run that, and now we're going to run this code. And we see that the array shows up as 0, 1, 2, 3, 4, 5, 6. And of course, it doesn't include 7, but it includes the 0, which is the default value. Now we're going to make a new code cell. And in this code cell, we're going to create a second array. We're going to call this array array2, very generic name, and we're going to make it equal to the np.arrange function. And the arguments that we're going to pass into it is a range of values from 1 to 5, which is going to be, and we're going to put it like this: 1, 5, and we're going to manually cast the data type of this array to float. So we're going to do dtype is equal to float. Okay, one thing that I want to cover over here is a very useful thing in Google Collaboratory. This is called the quick docs. Over here, you might have seen this thing popping up when we were writing our code. And it's very useful when you have something new in Numpy or any other library that you're using in Google Collaboratory. It will give you some context about what this function is. So for example, over here it says return an evenly spaced value within a given interval. This is the definition of what this function does. Also, at the bottom we see parameters of this function, or the arguments of this function. We have the start, stop, step, dtype, and what it returns. It returns an array of evenly spaced values. And over here at the bottom we have examples of how this code works. This is very useful when something is not shown in the tutorials and you want to use a new function. you can look at the quick docs to get some context about what the function is and how to use it. Over here, it says the parameters that the function has. But the main difference between parameter and argument, you might have heard us saying argument, but over here it says parameters. The main difference is that the parameters is what is declared in the function, while the argument is what is passed through when calling the function. Usually, parameter and arguments are referred to as the same thing. We will usually refer to them as arguments or keyword arguments, but don't get confused if we say parameters as well. Okay, so let's get back into the code. Now we are going to see the output of this array. So we're going to use a print and the RAPR function, and we're going to specify what we want to go inside and what we want to output. And in this case, it's array 2, and we're just going to run this code. As you can see, the array that outputs is values from range 1 to 5, but not including 5, and the data type for all these values are floats. We know that the np.arrange function returns an array of evenly spaced values, and the spacing between each of our arrays has been going up by 1 so far, which is the default step value. Let's create a new array, and right here I have a new code cell, you can just add one. And we're going to name this array array 3, and it's going to be equal to the np.arrange function, and we're going to specify the start, stop, and step values. And instead of using positional arguments, we are going to use the prefixes to see the position of our arguments. We are going to set the start of the range to equal 1. We're going to set the end of the range, so the stop value, equal to 6. And we're going to set the step value to equal 2. Like Python's range function, the step refers to the amount you go up by, or the spacing between the start and the stop values. So we're going to output this code using the print and RAPR function again. And it's going to be array 3. And let's just run this code cell. So we get an array from the range of 1 to 6, not including 6, and the step of the range is 2, meaning it goes up by 2. And the values in the array are 1, 3, and 5, which is the range. And note that each one of our arrays so far have all been 1D arrays. Whenever we use the np.arrange function, the output will always be one-dimensional arrays. The next function we are going to be using for range data is the np.linspace function, and the np.linspace function is very similar to the np.arrange function, but is used when you want to specify the number of elements in the returned array rather than step size. The np.linspace function will create evenly spaced sequences of numbers in a format of a Numpy array. The function takes two required arguments, which are the start and the end of the range. Let's write some code to get a deeper understanding of what happens. So we're going to create a variable, and it's going to be called linspace arr, and we're going to make it equal to the np.linspace function, and we're going to specify the start and the stop. But we're not going to use the prefixes. Instead, we're just going to use positional arguments. And the start of the range is going to be from 1, and we want the range to end at 10. And we're just going to output this code using the print and the RAPR function. And we're just going to run this code. Whoa, that's probably not what you were expecting. There are two things to note here. The first one is the end of the range is inclusive. While in np.arrange, the end is not inclusive, so the stop is not inclusive in np.arrange, but in np.linspace, it is. This is only true if the keyword argument endpoint is set to endpoint equals false. Also, the second thing to note here is that np.linspace creates evenly spaced sequences of numbers between an interval. If we want to specify the number of elements, we use the num keyword argument. In the example, we did not use the num keyword argument, so the default outputs 50 values between an interval, and it outputs it in a one-dimensional array. Another thing to note is that the np.linspace allows for manual casting using the dtype keyword argument. Now let's see what happens when we code this. I'm just going to create a new code cell here, And I'm going to make a new variable, and this one's going to be called endpoint ARR, and it's going to be equal to the np.linspace function. And the arguments are going to be 1 and 10, the start and the stop of the range. And we're also going to use the endpoint keyword, and we're going to set this equal to false. And now we're going to print this and using the REPR function as well, and it's going to be endpoint ARR. And now we're just going to run this code. Okay, so the output is a one-dimensional array of 50 evenly spaced values all the way from 1 to 10, but not including 10, because the endpoint is equal to false, meaning the end of the range is now exclusive, not inclusive. Usually when endpoint is not specified, the default is endpoint is equal to true, meaning 10 or whatever the end of our range is inclusive. Now we're going to create another code cell, and we're going to call this variable spaced ARR, and it's going to be equal to the np.linspace function again. And the arguments are going to be 1 and 10 again, and we're going to specify the num keyword. And we're going to set this equal to 5, and we're going to just print this out, and REPR spaced ARR. Okay, now let's run this. Okay, now we get a one-dimensional array of evenly spaced values from 1 to 10. But since the num keyword is equal to 5, instead of the default being 50, we get 5 elements in our array. Now we're going to make another code cell here. And we're going to call this casted ARR. And it's going to be equal to the np.linspace function again. Linspace. And the arguments are going to be 1, 10 again. And we're going to set it to have 5 elements in the outputted array again. And now this time we're going to use the dtype keyword, which we used previously, and we're going to put the data type of our outputted array to be integers. And let's just print this out using the REPR function again, and inside it's going to have casted ARR, and let's just run this code. Okay, now we get an array, but this time when we perform manual casting, it can sometimes skew the data in the way that the numbers are not evenly spaced. In the example above, we use the dtype keyword argument to manually cast the arrays to integers, whereas before it would automatically switch to the data type to be evenly spaced. For example, over here in spaced ARR, the output is evenly spaced values, and there's 5 of them, and they're all floats because that is what's required to be evenly spaced out. But since we casted it to an integer, it's now an outputted array that's not evenly spaced. 1, 3, 5, 7, 10. In this section of the video, we are going to be talking about reshaping data, but before we can get into that, we need to talk about dimensions and the shape of an array, and how they are described, which will be used in many other tutorials throughout the course, and in Numpy in general. In Numpy, the shape of an array is the number of elements in each dimension, and the shape property returns a tuple of array dimensions. We'll walk through array shapes in depth, going from 1D arrays to more complicated 2D and 3D arrays. Let's start with the 1D array, and the dimensions of a one-dimensional array can just be described as the number of elements in the 1D array. For example, look at the example on the screen. We have a one-dimensional array from values 1 to 5 inclusive, and the shape for this array would just be 5 because there's only one dimension, and the shape of an array is just the number of elements in each dimension. For a two-dimensional array, the dimensions are described as by the number of rows by the number of columns. In our example, the dimensions of an array are 3 by 3. The shape of this array would be described as 3 rows and 3 columns. For a three-dimensional array, an array that has 2D arrays as its elements, the dimensions are described by the layers/depth and the number of rows and columns in each layer or depth. In our example, the shape of this array is 2 layers, 2 rows, and 3 columns, and the dimension of this array is 2 by 3 by 3. Now let's take a look at this in the Google Collaboratory. We're going to make a new code cell here. And let's call this 1D. And it's going to be equal to the np.array function to create a 1D array. And what we're going to pass in is a Python list to create a 1D array. And it's going to be 1, 2, and 3. And now we're just going to output the dimension of this array. And how we're going to do that is using the ndim property. So we're going to do print repr function, and we're going to put in 1D, and we're going to put dot ndim. What this does is n dimension, meaning what is the dimension of this array. We know that it's a one-dimensional array, but it's going to print it out for us. And it says 1. Let's just close this, and we're going to print the shape of this array. And the shape of the array is just the amount of elements in each dimension. So we're going to do print repr, and inside the parentheses is going to be 1D, and it's going to be dot shape as our property. And what it does is returns a tuple of the dimensions of this array. Now let's run this. We get the dimension as 1, and we get a tuple of 3, comma, and nothing else after that. As you can see, it generates a 1-element tuple with a comma beside it. When generating a 1-element tuple, if you write only one object in parentheses, the parentheses are ignored and not considered a tuple. The reason why you need a comma for a single tuple is that tuple is an object delimited by a comma, not an object enclosed in parentheses. Now we are going to do the same for a 2D array, and we're going to make a 2D array, and it's going to be called 2D, and it's going to be equal to the np.array function, and we're going to pass in a 2D array, obviously. And 2D array is just Python list of lists. So let's create this. So it's going to be 1, 2, 3, and another list 1, 2, 3. And let's get the dimensions of this array using the ndim property. So we're going to do print repr 2d dot ndim. And let's just run this, and we get 2. So we have 2 dimensions in this array. To get the exact dimensions of this array, we're going to use the shape property. So we're going to do print repr, and it's going to be 2d dot shape. And this will return a tuple of our dimensions. And we can see that the first number is 2 and the second number is 3. Let's just click enter here, and we can see the exact rows and columns for our array. And for a 2D array, the dimensions are always the rows by the columns. So we have 2 rows, which is this first number 2, and we have 3 columns. Finally, we're going to do this for a 3D array. Let's name this 3D array 3D, and it's going to be equal to the np.array function. And inside the np.array function, we're going to have a 3D array. And a 3D array is just something that contains 3 nested levels of arrays, one for each dimension. So let's create this. After every comma, let's just click enter to see if it's been formatted correctly. And we're just going to check to see if it's been formatted correctly. And everything looks fine, so we're going to do print repr, and inside the repr function, we're going to do 3d.ndim to find the dimensions of this array. And we get it's a 3-dimensional array. And to find the exact dimensions of this array, we're going to do print repr and 3d.shape, and like always, it's going to return a tuple of the dimensions of this array. And previously we said that the dimensions of our 3D array is the layers, and the rows and the columns in each of these layers. The tuple represents layers, rows, and columns. And we can see that this whole thing is one layer. This is the second layer. And in each of these layers, there's 2 rows and 3 columns. Now that we have understood dimensions and the shape property in Numpy, we can look at reshaping data, which is very useful. Reshaping data is just as the name implies. changing the shape of an array to a new one. The function we use to do so is the np.reshape function, which takes two required arguments, one being the array, and second being the dimension of our new array. So let's look at this by writing some code. We're going to create a new variable. It's going to be called onShape. It's going to be equal to the np.arrange function, and we're going to put an a here. We know that the np.arrange function always returns a one-dimensional array. And in this case, it will return a 1D array from values 0 to 8, but not including 8. So let's just take a look at how this looks. We're going to do REPR, and we're going to do onShaped. And let's just run this. And what we get is a one-dimensional array from values 0 to 8, but not including it. Now, let's reshape this. We're going to create a variable. It's going to be called reshaped. It's going to be equal to the np.reshape function. And what we're going to put in is the new, or the array that we want to put in, which is onShaped, and the new dimensions of this array. And say we'll just put in 4, 2. You can't put any number here. The reason is that the product of these two numbers, or how many numbers that you have in your tuple, has to be equal to the amount of elements in the array that you're changing. So for example, we have onShaped. It has 8 values from 0 to 8, but not including it. So 1, 2, 3, 4, 5, 6, 7, 8. And we want to change it to a two-dimensional array with 4 rows and 2 columns. 4 times 2 is 8, which equals the amount of elements that we have. We couldn't put this to 4, 3, because it would be 12, and we don't have 12 elements in our array. Now, let's just print this array, or output this array, using the REPR function and the print function, and we're going to put in reshaped. And let us run this code cell. Now, what we get is a two-dimensional array with 4 rows and 2 columns. We can use the special value of -1 in at most one dimension of the new shape. So let's take a look at what this means. We're going to write some code, and we're going to create a variable. It's going to be called onShaped2, going to be equal to the np.array function. And what we're going to do is create a two-dimensional array. And it's going to be the same two-dimensional array from above. And let's output this. It's going to be REPR and onShaped2. Perfect. We get a two-dimensional array, 2 rows, and 3 columns. Now, let's reshape this. We want to reshape this into a 3-dimensional array. So we're going to create a new variable, going to be called reshaped2. It's going to be equal to the np.reshape function, and the arguments we have is the array that we want to change, onShaped2, and the new dimensions of this. We want a 3-dimensional array to be outputted. And let us put this the same arguments, so it's going to be 1, 2, and -1. Let's take a closer look at this. The 1 is the number of layers we want, so we only want 1 layer. We want 2 rows in each of this layer, and -1 is the special value. It's going to take the number of columns that it's required to create a perfect 3-dimensional array using 6 elements. This might not make so much sense, but once it's outputted, it'll make much more sense. Let us output this. And we're going to do reshaped2. Let's run this code cell. Perfect. What we get is a 3-dimensional array with 1 layer, 2 rows, and 3 columns. Let's print the shape of this array first. And we're going to do reshaped2 dot shape. And let's run this, and we see that the -1, the special value, took the number 3, because 1 times 2 times 3 is equal to 6, and we have 6 elements in this. While the np.reshape function can perform any reshaping utilities we need, Numpy provides an inherent function for flattening an array. Flattening an array reshapes it into a 1D array. Since we need to flatten data quite often, it is a useful function. Let's look at some code to get a better understanding of this. So we've created some variables up here before, and we have reshape2, unshape2, unshape, reshaped. Let's just take unshape2 for example. And we're going to print repr, and inside this we're going to do unshaped2 dot flatten with the parentheses on the outside. And if we just run this, we get our array in a 1-dimensional array. See, unshaped2 was a 2-dimensional array, and now it is a 1-dimensional array. It returns a copy of it. So if we print repr unshaped2 right here, it won't be this flattened array. It'll be what it was before, a 2-dimensional array. So the flatten function just returns a copy of the array, and it's very useful for just flattening an array. We can also transpose our data, which means it causes 2 or more things to change places with each other. And in our case, it's arrays. The function takes in a required argument, which will be the array we want to transpose. Let's take a look at some code to get a further understanding of this. We're going to create a variable, and it's going to be called new array. It's going to be equal to the np.arrange function, and we're going to put in 6 as the argument, so the values that are outputted will be from 0 to 6. But there's a problem. np.arrange function always returns an array, a 1-dimensional array to be specific, and the np.transpose function has to take in a 2-dimensional array or higher in order for it to work. And so we can do something here. We can use the reshape property, and we can reshape it to a 2D array. So let's do this. We're going to call this 2, 3 like this, and this means 2 rows and 3 columns, and it's equal to the 6 elements that we have. Let's just take a look at this, and we're going to do print repr new array. And let's just run this code cell. Okay, that's perfect. We get a 2-dimensional array with 2 rows and 3 columns from elements 0 to 6, but not including it. Let's create a new code cell here. And now we're going to call this variable transposed. And it's going to be equal to the np.transpose function. And inside we're going to put in the new array that we want to transpose. And it's just going to be called new array. And let's output this. Like so. And let's run this code cell. Let's take a look at what happened here. Previously, we had an array with 2 rows and 3 columns. Now we have an array with 3 rows and 2 columns. Let's get the shape of this array first. We're going to do print repr new array dot shape, and we get 2, 3. That is the shape that we put in. Let's get the shape of this transposed array dot shape, and we get 3, 2. So what happens here is the np.transpose for a 2-dimensional array, it switches the dimensions. So it switches the rows and the columns. So there will be, since there's 2 rows and 3 columns here, now it will be 3 rows and 2 columns. np.transpose also has a single keyword argument called axes, which represents the new permutation of the dimensions. The permutation is a tuple / list of integers with the same length as the number of dimensions in the array. It tells us where to switch up the dimensions. The axes keyword is very similar to the dimensions of an array. For example, for a 2D array, axis 0 is the rows and axis 1 is equal to the columns. And for a 3D array, axis 0 is the layers, axis 1 is the rows, and axis 2 is the columns. For this lesson, this is all you need to know. Later on in the course, we will take a deeper look at the axis of an array. Let's write some code to get a better understanding of what this all means. We're going to create a variable. It's going to be called permutation. It's going to be equal to the np.arrange function, and we're going to put in 24 here. So we're going to get values from 0 to 24, but not including it. Since we can't use 1D arrays in the np.transpose function, we're going to reshape this into a 3-dimensional array. So we're going to have it like 3, 2, 4. So 3 layers, 2 rows, 4 columns. And let's print this. And let's run this code cell. Before we create our other array, or the transposed array, let's just get the shape of this. And let's run this. And we get 3, 2, 4, matching what we reshaped it to. We're going to get back to this. Let's create a new code cell. We're going to call this axes, and it's going to be equal to the np.transpose function. And the argument that we want is obviously the array that we're going to put in, which is going to be permutation. And the other keyword that we can have is the axes, list of integers, which is optional. By default, it reverses the dimensions. Otherwise, permute the axes according to the values given. So let's take a look at this. We're going to create axes is going to be equal to, and it's going to be a list of integers, and we're going to do 2, 1, 0, like so. And we're going to print this array out. It's going to be axes. And let's also get the shape of this array. It's going to be RPR axes.shape. Okay, let us run this. Okay, so what happened here? Before we had 3 layers, 4 rows, 2 columns. Now we have 4 layers, 2 rows, 3 columns. And the shape of this is 4, 2, 3. The layers, rows, and the columns. Previously, we said that axis 2 refers to the columns for a 3-dimensional array. So we want to switch up the dimensions of the columns. So the columns over here, 4 columns, to come here first. So what happens here, axis 2 is the columns, and we match it with the columns that we had here, 4. And now it replaces it and becomes the layers. So now we have 4 layers. Axis 1 is the rows. So let's match up the rows here. So we have 2 rows in each. And we want to have 2 rows now. So it's going to be 2 rows. And 0 is the amount of layers. So let's match it up with the layers. We had 3 layers and it takes the place for the columns. So now 3 is going to take the shape of this, and it's going to be 3 columns in each layer. Sometimes we need to create arrays filled solely with 0 or 1. For creating these arrays, Numpy provides the functions np.zeros and np.ones. They both take one required argument, which is the array shape. The functions also allow for manual casting using the dtype argument. So let's create a new array. We're just going to call this zeros. It's going to be equal to the np.zeros function, and inside we'll specify the shape that we want. We want a 2-dimensional array with 4 rows and 2 columns. And let us output this, and let's run this code cell, and we get a 2-dimensional array all filled with zeros that are floats, and they have 4 rows and 2 columns. We can specify the data type that we want, and we want integers, not floats, so we can just add a comma and specify the argument and run this code. Now we get all integers. Let's create a new code cell, and we'll do the same for ones. we'll create a variable called ones, and it's going to be equal to the np.ones function. And inside here, we'll specify a 3-dimensional array. So we'll do 1, 2, 3. And let us output this. It's going to ones. And run this. And we got a 3-dimensional array, all floats, 2 rows, 3 columns, and 1 layer. If we want to create an array with zeros and ones, but to take a shape of another array, we can do so by using the inherent functions called np.zeros_like and np.ones_like. Let's create a new array. We're going to call this new arr. It's going to be equal to the np.arrange function. And we're going to put an 8 here. And let us just output this code. And we'll just put a new arr as our argument. And we get a 1-dimensional array from 0 to 8, but not including it. Now, we're going to create a new array. It's going to be called zeros2. It's going to be equal to the np.zeros function, but we're going to do np.zeros_like, and the argument that we put in is the array that we want this array to take its shape for. So we want to take the shape of this array, new arr. So we'll put this in right here, new arr, and let us output this code by using the print and the repr function, and we're going to put in zeros2. And now we get an array, a 1-dimensional array of all zeros, and there's 8 zeros to be exact. Now, let's create a new array. It's going to be called new arr2. It's going to be equal to the np.arrange function. And what we want is 24 inside here, so 0 to 24. But we're going to reshape this into a 2-dimensional array, 6 rows and 4 columns. And let us print this, new arr2, and let us run this code. Now we get a 2-dimensional array with 6 rows and 4 columns, and let's create ones2. It's going to be equal to the np.ones_like function, and we're going to take the shape of new arr2. And let us run this code after we output it. So we're going to do ones2, and let's run this. Now we get a 2-dimensional array filled with ones, and it has 6 rows and 4 columns because it took the shape of new arr2. That brings us to the end of this video. If you did enjoy, please consider liking and subscribing, and like always, the Google Collaboratory with the notes and the code will be down below in the description, and we'll see you in the next one.